Hello everyone, welcome to Geeks for Geeks. So let's talk about today's problem. Our problem name is kth smallest, right? So let's read the question first. Our question said you are given an array and integer k where k is smaller than the size of the array. The task is to find the kth smallest element in the given array. It is given that all the array's elements are distinct, right? So in this particular case, we are given the n value, which is 6, which is the size of your array, and in array we are just given the elements, right? And the value of k is given to us, right? So which tell us that I want that particular kth smallest element, right? So in that particular case, output will be 7, right? So here we just given l equals to 0 and r equals to 5, which is your pointer, left and right? So l is pointing to the first and r is pointing to the last, right? So it means you have r plus 1 elements, right? That will be the n value. Okay, so let's see how we can solve this problem, right? So I want kth smallest element, and to solve this problem we have multiple solutions, right? You can choose any solution, right? But the constraint, if you see, constraint said I want this that particular question will be solved under n log n, right? So let's see how we can solve this problem, right? So what I'm doing is I simply do kth smallest. So my main agenda is to solve this problem is let's do with the help of a heap, right? Here I just use the minimum heap. Okay, so yeah, we can use a kth smallest, we can use, sorry, max heap, right? So what I'm doing is I simply make max heap, right? That's my first step. And my max heap ka size will be up to k, equal to k, right? Equal to k, size will be equal to k. Okay, now if I make the size equal to k, right? So for example, we have max heap like this, just assume like that. Now can you please tell me, like, what's the kth smallest element? If for example your k will be 3, okay, if your k will be 3, in that particular case, what is my output? This is the first smallest, this is the second smallest, that particular element is the third smallest, which is at the top of your min heap, right? Max heap, sorry, max heap, right? So here also we use the same idea. What I'm doing is I simply make the max heap of k size, right? So in the first loop, what I'm doing is I traverse up to k, means 3 elements, right? So my max heap will be look like this, right? Okay, my max heap will be look like this. So what I'm doing after is, okay, I traverse this element first, right? We are at 3. I'm asking, I want k smallest element, k smallest element in my k smallest element from all the n elements, right? We just have to traverse all the array, and at the end of it, I simply want k smallest element in my mini, like that. Now I'm asking, this is the maximum value, this is the minimum value, right? I'm asking, your top element is greater than my this element, can that 3 will be added into your k smallest element? They said yes, I have that particular element which is greater than your current element. What we have to do is pop this, add that particular 3 into your max heap. So after that your max heap will be look like this, right? Okay, after that I just traverse at 20. I'm asking, 20 can be added in my k smallest element. They said no. Why? Because your top element said this is smallest, right? But your current element is greatest. So I simply neglect that part, right? Okay. Again, I go into the traversal part and we reach to 15, right? We have 15 elements. So I'm asking 15 maybe and add in your this particular list in k smallest element. They said no, because my maximum value is at the top. They said I am smaller than 15, no need to add it, simply go forward. Now at the end of it, your traversal will be completed. We have k smallest element in my this particular max heap, right? Now tell me, what's your answer? Top element is the kth smallest element. This is the first smallest, this is the second smallest, and this is the third smallest. So whatever we have at the top, return that particular thing. What we have to do is return pq.top, right? Like this. That's a simple indication to solve this problem, right? So first step which you have to keep in mind, I have to make max heap, and particular max heap ka size will be k, right? Equal to k always. Now we just have to traverse my array like that. Key, we just have to choose k smallest element in my min heap, right? In my max heap. At the end of it, whatever we have at the top, that particular is my kth smallest element, right? That's the intuition to solve this problem, right? So let's code this now. So the first step is, let's make your max heap, right? Okay. After that, your first step is, let's traverse up to k, right? So that we can make my minimum min heap ka size will be k. So I simply push that particular element, right? Now within this first loop, your PQ ka size will be k, right? Now what we have to do is, we just have to traverse the next element, right? Whatever we are left with my array, start from k and equal to r, right? That's it. So what we have to ask is, if my PQ ka top element is greater than array of I, it means we just have to pop that element. Let's pop this and add that particular current element because it's the smallest element, right? That's it. At the end, what we have to do is, we just have to return the top element, right? What we do in the try run part. Like this, it's very simple. Okay. Now let's compile and check it's working fine or not. Okay, yeah, the compilation is good. Let's submit and check. Okay, as you see, all the cases are passed, right? Okay, now let's talk about its time complexity. So time complexity is simple. In the first, what we have to do is, we just have to traverse my k elements, right? So it will be k, and we know that pushing into my max heap, it take log whatever the size of your heap, right? Here the size will be k. So can we say that in the first iteration, my time complexity will be k into log k. Why log k? Because your size of heap is equal to k, right? So if it's n, that's why we just have to say that k log n. But here the size will be k, right? We are very strict for that part. And the second for loop, we traverse the rest of the elements, right? Which is, we can say that n minus k, where n is the size of my element, right? And in that particular case, again, we just have to pop it or add it, right? And what's my value of size of your heap, right? It's k. So here also what we have to do is n minus k log k, like this. So at the end, we can say that it's k log k plus n log k minus k log k. Okay, so at the end we can cross this and we can say that it's n log k, right? That is your time complexity to solve that problem. It's better than n log n, right? So that's it. And if we talk about space complexity, whatever we use here is my minimum heap, right? And that complexity will be k, right? Like this. Okay, so that's all from my end. Hope you understand the intuition and solution. Thank you so much.